every type of planetary magnetic field. Space is complicated. We make it simple. An invisible force field is currently standing between you and a slow radiation blasted death, and you've never once had to think about it. Every planet in the solar system has a different relationship with its own magnetic field. Some have a strong one, some have a patchy leftover one, some have none at all. And the difference between those categories is, in more than one case, the entire difference between a planet that could support life and one that definitely can't. We're going in order from the strongest, most active fields to planets with none at all. Then we'll sort them a second way by what's actually generating each one. Because on this list, the exact same basic phenomenon comes from wildly different sources depending on the planet. Earth's magnetic field. We begin with the one keeping you alive right now, generated deep within the planet by a process called the geodynamo, churning electrically conductive molten iron in Earth's outer core combined with the planet's own rotation, generating a self sustaining magnetic field that extends far out into space, deflecting the bulk of the sun's dangerous solar wind around the entire planet rather than letting it strike the atmosphere directly. Here's the fact that should genuinely bother you: Earth's magnetic field isn't a fixed, permanent structure at all. Geological evidence embedded in ancient volcanic rock shows the field has completely reversed polarity, north swapping with south dozens of times throughout Earth's history. And during a reversal, the field's overall strength can drop dramatically for centuries or longer before fully reestablishing itself, temporarily leaving the planet with meaningfully less protection than it currently has. Here's the part that lingers. The field is also currently weakening in one specific region called the South Atlantic anomaly, where the field dips low enough that satellites passing through the area experience noticeably higher radiation exposure than anywhere else in orbit. A small scale real time preview of exactly the kind of gradual weakening that precedes a full magnetic reversal. Jupiter's magnetic field. Here's the twist: Earth's protective bubble is genuinely impressive, right up until you compare it to Jupiter's, which makes Earth's field look almost negligible by comparison. Jupiter's magnetic field is roughly 20,000 times stronger than Earth's, generated not by molten iron, but by an enormous layer of metallic hydrogen deep within the planet, hydrogen compressed under such extreme pressure that it behaves like a liquid metal, conducting electricity far more effectively than anything in Earth's own core. Here's the fact that should genuinely bother you. Jupiter's magnetosphere, the region of space its magnetic field actually dominates, is so enormous that if it were visible to the naked eye from Earth, it would appear larger in the sky than the full moon, despite Jupiter itself being hundreds of millions of kilometers away, one of the largest coherent structures in the entire solar system, larger by volume than the sun itself. Here's the part that lingers. This same colossal field is directly responsible for the intense radiation belts discussed elsewhere on this channel, belts so dangerous that they represent one of the primary reasons a crewed mission to Jupiter's moons remains firmly off the table for the foreseeable future. Jupiter's magnetic field protects nothing living out there. It simply traps and concentrates the danger instead. Mercury's weak but genuine magnetic field. Here's the reframe. This is the coincidence that shouldn't exist, according to the standard models used to explain planetary magnetism. Mercury is small, rotates extremely slowly, and by most theoretical expectations should have cooled and solidified its core long ago, both factors that should have shut down any internal dynamo process entirely. And yet, Mercury does have a genuine, if comparatively weak, magnetic field, roughly 1% the strength of Earth's, confirmed directly by spacecraft measurements. Here's the fact that should genuinely bother you. Planetary scientists still don't have a complete, fully confirmed explanation for exactly how Mercury manages to sustain this field at all, given how thoroughly it violates the simple expectations built from studying Earth's own dynamo. Leading theories propose a partially molten core layer maintained by unusual internal chemistry, but no single model has been definitively confirmed as the actual mechanism. Here's the part that lingers. Mercury's field is also noticeably lopsided, offset significantly from the planet's geometric center, rather than emerging from it symmetrically the way Earth's does. an asymmetry that remains itself. It's only partially explained, meaning the smallest planet in the solar system is quietly one of the most stubborn open puzzles in the entire study of how planetary magnetic fields actually work. Mars's fossil magnetic field. Here's the fact that reframes an entire planet's history around a magnetic field that no longer exists at all. Mars has no meaningful global magnetic field today, but detailed surface surveys have detected strong, localized patches of magnetized rock, particularly concentrated in the planet's ancient southern highlands, direct physical evidence that Mars once had a strong, functioning global dynamo similar to Earth's, sometime in its early history over 4 billion years ago. Here's the fact that should genuinely bother you. Current scientific consensus links the shutdown of this ancient field directly to Mars's ongoing atmospheric loss, discussed elsewhere on this channel. Without a magnetic field deflecting the solar wind, Mars's atmosphere has been slowly, continuously stripped away into space for billions of years, a process still measurably ongoing today, that Earth has been almost entirely protected from purely because our own dynamo never shut down the same way. Here's the part that lingers. The magnetized rock patches on Mars are essentially a fossil record. Frozen in place at the moment, the ancient magnetic field's lines pass through them, meaning scientists can read the ghost of a magnetic field that hasn't actually existed for billions of years directly off the surface of a planet that lost the one feature that might have kept it habitable: Venus's induced magnetosphere. Here's the fact that pushes this category into the strangest, most indirect version on the entire list. Venus, similar in size and composition to Earth, has no internally generated magnetic field of its own at all, likely because its extremely slow rotation isn't sufficient to sustain the same kind of dynamo process powering Earth's core. And yet, Venus isn't left completely undefended. Its thick atmosphere generates what's called an induced magnetosphere, a weak, temporary magnetic structure created indirectly as the solar wind's own charged particles interact with and are deflected by electrically charged layers high in Venus's dense atmosphere. Here's the fact that should genuinely bother you. This induced field offers meaningfully less protection than a true internally generated field like Earth's, and current models suggest it directly contributes to a slow, ongoing loss of Venus's own atmospheric material into space, similar in basic mechanism to what happened to Mars, just proceeding at a different rate given Venus's much thicker starting atmosphere. Here's the part that lingers. This means a planet doesn't strictly need a true internal dynamo to have some form of magnetic protection at all. Venus proves an atmosphere alone can generate a weaker secondhand version of the same basic effect, a genuinely different category of magnetic field from every other entry on this list, created from the outside in rather than the inside out. Saturn's unusually symmetrical magnetic field. Here's the fact that closes the gas giant portion of this list on a genuine, still unsolved theoretical puzzle. Saturn's magnetic field, like Jupiter's, is generated by a deep layer of metallic hydrogen. But unlike Jupiter's, and unlike every other planetary field measured in the solar system, Saturn's field is almost perfectly aligned with its own rotational axis, showing essentially no measurable tilt at all. Here's the fact that should genuinely bother you. According to a foundational principle in dynamo theory called Cowling's theorem, a magnetic field generated by a perfectly symmetrical process should be theoretically impossible to sustain over long timescales at all, meaning Saturn's suspiciously perfect axial alignment isn't just an unusual coincidence. It's a genuine theoretical problem that current dynamo models struggle to fully explain. Here's the part that lingers. One leading proposed explanation suggests a stable layer of helium rain, discussed in relation to gas giant interiors, may be subtly smoothing out and symmetrizing the field generated deeper within the planet before it ever reaches the surface, meaning Saturn's rings and its magnetic field may both, in different ways, be shaped by the same deep, slow internal weather happening far beneath anything a telescope can directly observe. Planets and moons with no magnetic field at all. Here's the fact that closes this list on the most exposed, most unprotected end of the entire spectrum. Several bodies in the solar system, including the Moon and Mars in its current state, have no meaningful global magnetic field whatsoever. leaving their surfaces directly exposed to the full force of solar and cosmic radiation discussed elsewhere on this channel, with no planet-wide deflection at all. Here's the fact that should genuinely bother you. This isn't purely a historical curiosity. It's a direct practical engineering constraint on any future crewed mission to these locations. Since astronauts on the lunar or Martian surface can't rely on a planetary magnetic field to reduce their radiation exposure the way life on Earth's surface always has, requiring dedicated physical shielding built directly into surface habitats, discussed elsewhere on this channel, to compensate for a natural planetary feature that Earth provides for free and these worlds simply don't have. Here's the part that lingers. Jupiter's icy moon Europa, despite having no magnetic field of its own, sits deep enough inside Jupiter's own colossal magnetosphere that it experiences intense radiation exposure anyway. Proof that even a moon with zero magnetic activity of its own can still end up in one of the most dangerous radiation environments in the entire solar system, purely by being unlucky enough to orbit something else's magnetic field instead. Exoplanet magnetic fields inferred but not yet confirmed. Here's the fact that closes out the categories with the frontier of current research, extending this entire question far beyond our own solar system for the first time. Astronomers have begun searching for indirect evidence of magnetic fields around exoplanets, primarily by looking for the specific radio emissions or unusual atmospheric interactions a strong planetary field would be expected to produce, similar in principle to the interactions already confirmed and studied around Jupiter. Here's the fact that should genuinely bother you. As of now, no exoplanet magnetic field has been fully, unambiguously confirmed with the same certainty as the fields measured directly by spacecraft within our own solar system, meaning one of the most important habitability factors discussed elsewhere on this channel, an active magnetic field protecting a planet's atmosphere from stripping, currently can't be directly verified for any of the thousands of confirmed worlds beyond our own solar system. Here's the part that lingers. This specific gap in our knowledge means every discussion of a distant exoplanet's habitability currently has to treat its magnetic field status as an open, unanswered question, exactly the same uncertainty that once surrounded Mars until spacecraft finally arrived and read the fossil magnetism directly off its surface. Let's sort these 8 again, a different way, not by strength, but by what's actually generating each field. On the classic internal dynamo end, Earth and Mercury, both generating a field from molten, electrically conductive material churning deep within a rocky core. On the metallic hydrogen end, Jupiter and Saturn, both powered by an entirely different mechanism unique to gas giants, involving hydrogen compressed into a liquid metal state no rocky planet could ever replicate. On the induced secondhand end, Venus generating a weaker borrowed field purely through atmospheric interaction with the solar wind rather than any true internal process. On the fossilized, no longer active end, Mars, whose current total lack of a global field sits directly on top of the physical magnetized rock evidence of a much stronger one it used to have. And on the fully unprotected end, the moon and every other body on this list generating no field of any kind, internal or induced, leaving their surfaces to face space with no magnetic defense at all. It's worth pausing before we close on the specific visible proof that Earth's magnetic field is actually working, right above your head, on any clear night at high enough latitude. The aurora, the shifting curtains of green and red light seen near the poles, are a direct, visible signature of the magnetic field doing its job, charged particles from the solar wind, funneled by the field's own shape down toward the poles, rather than being allowed to strike the atmosphere everywhere at once, colliding with atmospheric gases and causing them to glow. Here's the fact that should genuinely bother you. This means the aurora isn't simply a beautiful, unrelated phenomenon that happens to occur near a magnetic field. It's the field actively, visibly redirecting genuinely dangerous radiation away from the rest of the planet and concentrating it into 2 small, relatively survivable polar regions instead, a nightly light show that is, quite literally, your evidence the shield is holding. Here's the last thing worth sitting with. You have spent every single day of your life standing underneath an invisible, constantly active force field, generated by churning molten metal thousands of kilometers beneath your feet, deflecting a stream of dangerous charged particles that would otherwise be steadily stripping away the very air you're breathing right now. The same slow process currently still happening, unopposed, to the planet next door. Not bad for stick figures on a rock.